Here's a quick overview of operations with complex numbers. The first thing that we need to know is that I squared is defined as being equal to -1. So that means that I is the square root of -1. So for example, if we have the square root of -5, that's really the square root of -1 times 5, which means that square root of -1 I can rewrite as I, and then the square root of 5. If I have the square root of -36, I can rewrite that as the square root of -1 times 36. The square root of -1 we know is I, and the square root of 36 we know is 6, which means I can rewrite this as 6i. Complex numbers are defined as a plus bi, where a is our real part and bi is our imaginary part. For adding and subtracting complex numbers, you all have to combine like terms. So if we have 8 minus 2i plus 4 plus 6i, what I do is I combine the 8 and the 4. So I say 8 plus 4, and then I combine the -2i and the 6i. So I can say minus 2i plus 6i. Now I just combine like terms. So 8 plus 4 is 12, and -2i plus 6i is plus 4i. I always write my final answer as having my real part first and then my imaginary part. So here is our final answer. If I'm subtracting, the one thing I have to be careful of is this minus sign. I have to remember to distribute to both the terms so that they're both being subtracted. So first off, I can say 5 minus 3i, and now minus -2 becomes plus 2, minus 4i becomes minus 4i. Now I'm going to combine like terms, so I will combine the 5 plus 2, and then I'll write the imaginary terms, so that minus 3i minus 4i. And finally, I combine 5 plus 2 is 7, minus 3i minus 4i is minus 7i. For multiplying, I have to remember that the I squared is equal to a -1. So anytime I end up with an I squared, I can change it to -1. So if I have 3i times -5 plus 2i, what I can do is distribute and multiply. So first I'll say this is minus 15i plus 6i squared. Now that I squared is really a -1. So what I can say is this is really 6 times -1, or -6, minus 15i. And notice I put the real part first and then the imaginary. If I have something like 7i times 3i, I just multiply the 7 and 3 to get 21. I times I is I squared, and that I squared turns into a -1, so this is really 21 times -1, which is really -21. Next up, if I have something like this, I have to remember to FOIL. So I'll do first, 2 times 4 is 8. Outer, 2 times 5i is plus 10i. Inner, -3i times 4 is -12i. And last, -3i plus 5i is -15i squared. Now I'm going to combine like terms and change any I squareds I see into a -1. So I'll say this is 8, and now I'll combine my like terms. My 10i minus 12i will give me -2i minus 15 times -1. That -15 times -1 becomes a positive 15. So I'll have 15 plus 8 minus 2i. Finally, I'll combine those like terms, and I will get 23 minus 2i. Last up, we have our complex conjugates. So this happens if I have a term that's a plus bi. The complex conjugate would be a minus bi. So for example, if I have 7 minus 2i, the complex conjugate becomes 7 plus 2i. If I have -6 plus 3i, the complex conjugate becomes -6 minus 3i. We're going to use this to our advantage because if you multiply two complex conjugates, you actually just get a real number. So we're going to use this to help us rationalize. When we're dividing complex numbers, we have to remember to rationalize by multiplying by the conjugate. But the conjugate that we pick is in the denominator. So even if there's a complex number in the numerator, we're going to multiply the complex conjugate in the denominator. So this first example is actually even easier than it seems. So in our denominator, notice we don't even have an addition or subtraction problem. All we have is an I. So what we're going to do is simply multiply by I over I. And I like to add parentheses around this. And now I just multiply numerator, so I'll do 9i and 12i times I, so I'll get 9i plus 12i squared. In the denominator, I will get 3i times I, which is 3i squared. Now I'm just going to simplify, so any I squareds I see get turned into negative ones. So this becomes negative 12 plus 9i over negative 3. And last, I can simplify a little bit by dividing both terms by negative 3. So I'll get 4 minus 3i. And as usual, I have a real part and an imaginary part for my answer. If I come across something like this, what I have to do is figure out the conjugate of the denominator and multiply both numerator and denominator by that number. So I'm going to multiply both by 3 minus 4i. And I like to add parentheses so that I remember to distribute. So now I'll go ahead and multiply the numerator. I'll do FOIL, so 5 times 3 is 15. 5 times negative 4i minus 20i. Negative 2i times 3 is negative 6i. And negative 2i times negative 4i will give me a positive 8i squared. Now in the denominator is where something cool happens because we're trying to rationalize. So I get a 9, then I get a minus 12i plus 12i minus 16i squared. When I combine like terms, something really cool is going to happen where the denominator is going to be rationalized. So let's see what happens if I combine. So I'll get a 15 minus 26i plus 8, and I'll turn that I squared, both of these, into a negative 1 times 8. Now in the denominator, notice the negative 12i and the I cancel, so I'm just left with 9 minus 16 times negative 1. So my denominator is actually completely real at this point. There's no more complex numbers. So finally, I'm left with 15 minus 8, which will give me 7 minus 26i over 9 plus 16. That 9 plus 16 is 25, so I'll get 7 minus 26i over 25. And finally, I'll divide it up so that it's one number. So 7 over 25 minus 26 over 25i. And there is our final answer. So that's just a quick overview of complex numbers.